that's available in GitHub and start working on it. So yeah, that's how I want to say on that end. Cool.
All right, that was good, Karthikeya. Thank you so much. Have a nice weekend ahead and really appreciate your time. And yeah, take care. Have a nice weekend. Ta-da.
See you
Bye.
all, folks. Yeah.
All right, Nemgama, I think it's one session until we wrap it up. We both wrap it up, right? So what is the next session we are looking at?
Exactly. I hope everyone is still engaged in the conference.
Yeah.
We have a lot more interesting sessions to look forward to. Talking about that, our next session is going to be about what it takes to be an NLP engineer. So let's welcome our speaker, Usman.
Hi, Usman. Welcome to Global AI Student Conference. How are you doing today?
Hey Stephen, thank you for having me here. Can you hear me properly?
Yeah, you are loud and clear, and we can see very clearly. Thank you so much for your time, Osman. I really appreciate it. We won't take much of your time. Feel free to go ahead and share screen, and then you can get started.
Sure,
All the best.
thank you. Okay. Hey everyone. So today we're going to be talking about what it takes to be an NLP engineer, and this is just like sort of an introduction about me. Who am I? I'm a Beta MLSA, and other than that, I'm a Microsoft certified trainer. I have conducted sessions for well over 500 people, and other than that, I'm professionally a machine learning engineer in NLP, and all of the other certifications you can see it on the screen. So before any further video, let's get started. This is going to be the agenda for the talk. We're going to be looking at machine learning because in order to address the elephant in the room, which is NLP, you first need to know what actually is ML. And you need to understand how ML, DL, AI, and NLP works in order to properly dive deep into NLP. So this is the agenda for the talk. Let's move forward. Now, the very first question most people who just start off with machine learning have is what even is machine learning? And they usually come across the equation like Karthike also explained, which was y is equal to mx plus b. And that is like the very first thing that comes up if you search what is machine learning, and it can get a bit tedious. I've simplified it for you. Like machine learning is the process of building models that can understand and predict patterns in text, numeric, and visual data. It doesn't have to be just numbers, or it doesn't have to be just images or those sort of things. It covers a very broad perspective. So this is like sort of a Venn diagram. This will help you visualize what actually is ML, DL, and AI. AI is you can say the master class, and ML is its subclass, and DL is its subclass as well. And you can see that data science, like this is one of the like I've seen 10 to 20 posts every 1 to 2 hours on LinkedIn on people getting jobs in data science, like in and getting a three-figure, six-figure salary in that. So data science is also covered in this domain too, and you can see that it is like standing out from this domain as well. That's because you also deal with statistics and data science as well. That's the reason it's here. Okay, so moving forward, uh, we have three types of machine learning. We have supervised, unsupervised, and reinforcement learning. And then each of those types have two different types. Like we have regression in supervised learning and classification. You can think of regression as like sort of problems in which you're dealing with continuous variables. Like whenever you're predicting something that is continuous, that comes under the domain of supervised regression. And when you're dealing with discrete values, like whenever you're predicting something which is something discrete, it comes under the domain of classification. And same goes for unsupervised. We have clustering and dimensionality reduction, where you basically we're not providing any label data to our models in unsupervised learning. And then we have reinforcement learning. This is something which is like applicable to real life, and this you can everyone has heard about Tesla, right? And that can come under the reinforcement learning because it's real time decision making. It works on the principle of reward and punishment model. So these are just like the basic info that you need in order to get started in NLP. Okay. This will help you understand the entire ML space much better. We have real life examples here, and if you guys want to take a screenshot of this will help you, especially if you're a newbie. Okay, so let me move forward. Now, what can you do in ML? You can you can be an AI engineer. You can cover the broader AI perspective and deliver AI applications, or you can uh, work as a machine learning scientist or an engineer. And all of the other domains are listed here. And the top domains that are in AI are NLP, computer vision, and data science. Other domains are there as well, but these are the most prominent ones. In computer vision, you're usually dealing with problems which uh, are related to images or videos, and in NLP, you're usually dealing with problems which are related to text. So, we are going to be covering NLP. We're not going to be covering computer vision. Kartike, or like another speaker already covered that. Okay, so now we're starting NLP. Now, you might you might put yourself in this situation. You might be thinking, what is NLP? Like, it sounds so much like a buzzword. Let me break it down for you. It's not that big of a thing. It's really like a simple domain, if you might say. Uh, Everything that is related to text, and you're using an interaction between the computers and the human language, and you're building something off of that, and so that your model understands the natural language, that comes under the domain of NLP. It's a subfield of linguistics, computer science, and artificial intelligence. It like overlaps all of these domains, and it can be either text or speech. Like, it's not only that you're dealing with textual data in NLP. There's also an audio or speech part in the NLP space. Okay, so now we have two different types of NLP. We have NLU and NLG. NLU is natural language understanding, and NLG is natural language generation. And what do both of these domains do? We'll see in the next few slides. This is like the Venn diagram of NLP, where NLP lies. You can see that just like data science, a lot of the space is being covered by linguistics, and like NLP lies somewhere in between artificial intelligence and linguistics. That's because if you ever had a chance to work with NLP problems, you might have seen that a lot of these problems come are not related to computer science at all. Like, let's say you're writing a regex or a pattern matching algorithm in NLP for your pre-processing stuff, and like all of the rules that you've written for your regex, they are nothing related to computer science. They are always related to linguistics. Like, subject should come before the verb or after the word, and context-free grammars and those sort of things. So yeah, moving forward, this is the difference between NLU and NLG. In NLU, you're usually dealing with decisions and actions. Yeah, and you're also dealing with classification, NER, sentiment analysis, and clustering. Like, you're trying to understand what the text means. Let's say I am saying, I'm not feeling well today. What does this text mean? What category does it belong to? Does it belong to happy category or a sad category, those sort of things. This comes under the NLU uh, domain. And when you're dealing with text generation, like whenever you're generating something, you all might have heard about GPT-3 or GitHub Copilot. That comes under the domain of NLG because you're just providing your model instructions on what to do, and your model will generate the entire text for you. Some of the prominent examples are LSTMs and BERT. BERT is really prominent in the industry right now, and I really recommend you guys to look into BERT. Okay. And what can you do with NLP? That is like the main question people have. You can do text classification. As I said earlier, if I'm stating that I'm not feeling well today, what category does my statement belong to? It belongs to a happy category or a sad category. Or let's say I'm traveling today, or let's say I'm writing a blog which is about food. How do you classify your article so that it automatically detects its category? You might have seen some news websites, they have proper sections for categories, they have proper sections for subcategories, they have proper tags and everything. Do you think that a person can manually do everything? Like there is around 5 to 10 articles which are published every now and then, like in every 15 to 20 minutes. And how can you keep up with that? Like you have to have a huge team in order to do that sort of stuff. But if you bring NLP to the table, you don't have to worry about anything. You can automate everything in that. You can automatically generate the tags with name entity recognition. You can also classify your articles with text classification. You can also do some sort of sentiment analysis in the comments or something else. You can also make chatbots in it as well. And if uh, like you're dealing with a summarization task, you can deal with the summarization as well. And some of the examples of NLP is, you can see one example here. This is dependency parsing. What this does is this basically parses your sentence, and it evaluates your sentence and uh, visualizes what word is dependent on which other word in that same sentence. You can clearly see that it has correctly identified that a is a determiner to a sentence, and the sentence is an attribute of and is the noun subject of this. And you can like start off small, like start off with words and then move towards sentences and then towards paragraphs and then towards entire articles and then maybe towards entire corpuses. And then we have another example called named entity recognition. Let's say you're writing an article, and that article is about, let's say it's about the new president that has been selected for the US, and you want all of the candidates to be detected from your article automatically. And whenever a person queries on Google or maybe your own custom search engine, that who were the candidates for let's say 2021 elections, your NER model should be able to detect those persons from your article and present them to your user. So these sort of problems are uh, they usually come under the domain of named entity recognition, and you can detect almost anything with it. This is an example of it. This is done via Spacey. We'll see some resources by the end of the slides on how you can achieve these sort of things. And what does the normal NLP pipeline looks like? Let's say you're hired as an NLP engineer and you're asked to like make a model for your company, and you have to make a productionized model which can sustain like different scenarios. So you start off by data acquisition. You acquire the data, and that can be done by various techniques. You can get data in the form of flat files. You can get data from other databases, and totally depends upon the usage. It varies from company to company. Okay, then you have to perform text cleaning. Uh, like this is I might say this is the most important step in the entire NLP pipeline, because if your data is not cleaned and it's not cleaned properly, you will see issues by the end of the pipeline, and by that time you have wasted your precious time in training the model, evaluating the model, and all of that stuff. So you need to spend some extra time in the text cleaning phase, because this cleaning is different from the cleaning in other domains. Then you have to pre-process it, and then you have to feature engineer it. You have to extract features from your text. You have to remove the stop words and all of the unimportant words in that. Then you have to do the modeling. This is like you can use normal ML models for NLP. It's not that different. The only thing different here is the feature engineering part, because you have to convert your text features into numerical features, because your model doesn't understand text. It only understands like numerical values. So in order to convert that, you can use multiple techniques, and then you have to evaluate your model. And if uh, the model is not performing correctly, you can go back to the pre-processing step, and this cycle goes on. Then you go towards deployment, and then you monitor and update your model as time passes. And then we have the text pre-processing pipeline. This is the thing that I was talking about, that you need to clean your data in such a way that it it doesn't affect your model by the end of your pipeline, and rather it improves your performance as well. So you start off with your text document, then you segment your sentences. Like you have an article, you split it into sentences, and then you split those sentences into words. This is called sentence tokenization or segmentation, and this is called word tokenization. And then we have stop words like is, am, I. These sort of things are called stop words. These do not add any meaning to the sentence, so we need to remove it. Then we need to lemmatize it. Lemmatization is like the base form of a verb. Let's say I'm saying winning, and ing, that's a suffix, and we do not need that, so we need to convert that into win, because that's the base form. That's called lemmatization. And then we have POS tagging, dependency parsing. We've already looked into that. We have non-phrases identification, then we have NER, and then conference resolution. This is sort of a dependency parsing as well, but it's mostly related to uh, nouns being related to pronouns and all of that stuff. And then we output the data structure representing the parsed text. And then the question arises, who even uses NLP? All of the major FANG companies use that. And one of the major use cases of NLP is in reviews. Like you've seen restaurant reviews in almost every website. Amazon, not only restaurant, like every review. You have product reviews in Amazon, you have like organization and business reviews in Google. You also have like almost everything that you deal with in your daily life, everyone is dealing with NLP. And why should you care about NLP? Like we're here talking about NLP, and why should you even care about it? And why shouldn't you go towards computer vision and convolution neural networks? Well, the thing is, computer vision and CNN are not bad. I'm not saying that they are better or this is better. All I'm saying is we're just comparing both of these things. And the major reason for being in NLP is that there is a lot of research that needs to be done in NLP. And almost most of the professors that I've met in the university are doing research in NLP as well as compared to other domains. And like major companies are also doing research in NLP too, like GPT, that comes under the domain of NLP as well. GitHub Copilot, that comes under NLP as well. Like you will see this field booming up really fast. And this is also a very less saturated field. Not everyone knows about it. And you have a like really bright chance in excelling in it. lastly, you will never get bored. There is always something new. Like there was a trend of LSTMs, and then when people started they started to get proficient in it, then birds started, and it might be possible that in a few years something else will come, and everything is interesting that is coming in the space of NLP. So these are the responsibilities of an NLP engineer. Let's say you're hired as a NLP engineer, and what do you hope to do? Like this can be your JD. You can like have a look at it, and if you're already studying NLP, you can prepare for these sort of things. You need to design and develop NLP systems, define appropriate data set for language learning, effective text representation to transform natural language into useful features. This comes under the domain of feature engineering, by the way. And like, how should you learn NLP? Uh, I always tell people that you shouldn't directly dive into NLP. You should first like focus on your foundations and get a stronger theoretical grip on things before moving on to practical stuff. Because practical stuff isn't that much difficult. Like Python, you can write a three liner, and that can like train an entire model and like test it as well. So you don't have to worry about implementing it. You have to spend an extra time in like building a good foundation in your ML and in NLP. You should start off by C++ as a first language. And many people might disagree with me that we should always start with Python or JavaScript. But the thing is, when you start with C++, you usually like it might seem difficult to you, but it is really helpful for you in the long term because it tells you what is going on the back end. Like you're assigning data types to variables, you're using pointers, how is the data stored, and what happens if you store a different type of variables in a single array. And like there's a lot of stuff that you can learn if you start with C++. So this is my recommendation, and you'll never regret it. And then after you've learned C++, then move on to Python. No one is saying that you shouldn't start learning Python. I'm just saying that this should be your priority, and then the second priority should be Python. Then start off with OOP, and then start off by the theoretical foundation for NLP and machine learning. I'll also state some resources in the upcoming slide as well, and then you can do all of these stuff as well. Also, you can go to my GitHub because, like, since I'm an open source contributor, I strongly believe in the open source world, and I've been committed to open source as well. And you can find a lot of resources related to NLP and ML on the GitHub, which are totally open source. If you want to contribute to it, you can contribute to it as well. And then the like specific resources that I would like to recommend are the first one is Andrew Ng's Coursera course. Like this is a must-have. Like if you're coming into AI and if you haven't done Andrew's course, like it is considered a sin. You have to do it. Okay. And then another recommendation is called DataCamp. Datagam is like a great starting place. They have a proper path for data scientists, proper path for data engineer, and all of the paths are clearly defined. You can like go there and check them out. They have free courses as well, and yeah, there's a YouTube channel called IntelliPath. They have a NLP course as well. I would highly recommend it. They have spent a lot of time. Like curating the course, and I will really recommend it. And I would also recommend you guys to look into GitHub Student Pack. GitHub Student Pack is an offer for students by GitHub, which provides you a lot of features. Like it provides a lot of services to you for free. And then I would highly suggest going for Microsoft Azure as well. And if you're a student, you can get a lot of resources for free. And last but not the least, Microsoft Learn. They have like a really good curated platform where everything is separated into separate modules, and it is really summarized well. I would highly recommend you guys to watch it. And what do you need to get started in terms of tool? All you need to do is install Anaconda, and you need to install Microsoft VS Code. That's it. You do not need to install anything else. Uh, you can just start off with Python as well, but Anaconda comes with Jupyter Notebook and all of other stuff. So it can help you in the long term. Okay. So moving forward, there are some myths in NLP and ML that you need a lot of math in ML. And believe me, you do not need a lot of math in ML. And I'm not saying that you don't need math at all. You do need that. You do need it. But I'm not saying that you need a lot of it. You just need to have a sound understanding of whatever like you're working with, whatever you're dealing with. Like if you've come to graduation, believe me, you are more than capable um, in dealing with math problems that you face in NLP or ML. And there is also some people who say you don't need math at all. I would disagree with them as well. As I said earlier, I'm not saying you need a lot of math, and I'm not saying that you don't need math at all. You don't need to be at the extremes. It's not like black and white. There's a gray area as well. So do not go towards extreme, and just have a sound understanding on what you're working with, and just go on with it. Okay. And then there are some people who miss all of these stuff and directly hop into machine learning. Don't do this, please. It will only hurt you. Do start off with like proper data structures, then problem solving, discrete structures, calculus, and statistics. And most the chances are, if you've done your graduation, you've already studied all of these things. But for self-learners out there, I know there are a lot of ML engineers who are self-taught. So please do follow the proper path. It will help you in the long term. And another question, that you need to be a PhD. This is like a really famous question asked on forums. No, you don't need to be a PhD in order to be in ML. I've seen people without degrees, without graduations, doing making a career out of NLP or ML. And lastly, you need to be a CS major to be an ML engineer. No, you don't need to be a CS major. You can be from electrical engineering. You can be from the English domain. You can be from anywhere and from any domain. There's no restriction. You just have to put in the effort. And there's some comparison between academia and industry. What is going on in the academia? You can like see the comparison here. Main thing that I would like focus on in academia and in the industry is that in academia you're usually dealing with some old and legacy papers, because you're trying to improve on the papers that were already published, and you're trying to come up with a better solution. And there are a lot of opportunities in it, and the language you might face are Scala, R, Python, Julia. And you might go like, what? Scala, R, Julia? Yeah, you can come across those sort of languages if you're working in NLP, because back in the days, Python wasn't that famous, and most researchers went on with whatever they felt comfortable at that time. And this is the average pace position. Things are not as fast as in the industry, and these sort of things do not include deployment most of the time. And in the industry, things are very fast paced, and you're mostly dealing with Python or SQL. And 80% of the time, you're dealing with deployment if you're working in the industry, and you're dealing with state of the art models as well, which are BERT and transformers. And again, if you guys want to connect with me, here's my LinkedIn, here's my GitHub, and this is my email. If you guys have any question, anything, just reach out to me, and I'll help you guys out in whatever way possible. So this is like the session for question and answer. If you guys have any questions, just let me know.
Well, that was a great session. Yeah, go ahead, Niyama. I'll follow up.
No, it's fine. It's fine. I was just saying that was an amazing session. Great memes as well. So you have addressed all the questions that were running through my mind. So I personally have only one question.
Okay.
So what is one application that you think that is using NLP to its full extent, to its full potential? For example, let's say for me it's Gmail, because nowadays Gmail is recommending when we forget something. Let's say we forget to attach a file. Gmail recommends us to do it. So what is one application, in your opinion, that is using NLP to its full potential these days?
Okay, like that's a really good question. And what I would say is the integration of NLP in your social media, because there are times, let's say if I'm a part of the student ambassador community, I get text all of the time. People are reaching out to me, and like my inbox is usually full, and I usually don't have time to reply to all of them on time. Like I do reply to them, but it takes time. What I would like is Facebook, Twitter, or like in whichever social media we're talking about, to integrate NLP services in it. So whatever like depending on the situation, our chatbot or whatever application we're using, it should automatically reply based off of the situation. And they already have our data, so why not make the best use out of it? And it is possible. It's not like I'm dealing with chatbots myself. I know it's possible, and with the resources that these social media giants Fang has, and they can do it. It's not a big deal for them. But yeah, that's my opinion.
Okay, that's very well put. Any other questions to you?
No, I'm good. This also reminds me that also in Outlook, right? If you forget to attach to forget to put an attachment, it will just say that, hey, I use Outlook, but glad that it also exists in Gmail. So that was absolutely great session, Usman. Thank you so much. Thanks for accepting the invitation. I know it's evening at your place. It's weekend, so you definitely like to go ahead and spend some time out. Thank you so much. And yeah, have a nice day ahead and see you soon. Ta-ra. Bye.
Thank you. Bye.